See Standard 12th Maths Chapter 6 Exercise 6.5 First sum. Find the parametric form of vector equation and Cartesian equation of a straight line passing through the point 5 to 8 and is perpendicular to the straight lines. Given two straight lines. So the required line is perpendicular to these two lines. See, first from these two lines, let me collect the parallel vector. Vector B is equal to, here this is a point in which the line passes through and parallel to this vector. Vector B, let me mark it as vector B, my 2i minus 2j plus vector k. When I take the second line, this is a point where the line passes through and this is the parallel vector. Let me take as a vector D. I plus 2j plus 2k. So, our required line is perpendicular to these two lines given. Therefore, our required line is parallel to the cross product of these two vectors. The cross product of these two vectors. Since a required line is perpendicular to these two lines, hence it is parallel to the cross product of these two vectors. So, let me find first B cross D. Vector B cross vector D. This is equal to I, J, K vector. 2 minus 1 minus 2, 1. And then 1, 2, 2. So, I into minus 4 minus 2 minus j into 2 2s are 4 minus 1 plus k into vector k into 2 2s are 4 minus minus 2. So, that becomes plus 2. This is equal to minus 6i 3 minus 3j plus 6k. So, the line or required line is parallel to this vector. So, already they given the line is passes through the point 5 to 8. So, the line is passing through a point 5 to 8 and parallel to minus 6i vector I minus 3j plus 6k. So, vector R is equal to, so vector A plus T vector B. Substitute the point 5i plus 2j plus 8k plus t into minus 6i minus 3j plus 6k. This is the parametric form. Next, you have to give the equation in Cartesian form. That is x minus point. You take the point here x minus 5 by is equal to y minus 2 by z minus k by. You have to write the direction ratios of this parallel vector here in the denominator minus 6, minus 3, then 6. So, this is the Cartesian form. That's all. Next is, let me do the sixth sum for you. Sixth sum. See the sixth sum. Find the parametric form of vector equation of the straight line passing through minus 1, 2, 1 and is parallel to the straight line. Vector R is equal to 2i plus 3j minus k plus t into I vector I minus 2j plus k. And hence find the shortest distance between the lines. So here the required line is passes through this point and also it is parallel to this. So the given lines and our required line both are parallel. That means they are parallel to the same, they have the same parallel vectors. So this is our required line. So required line, it passes through the point here -1, 2, 1. See, and also it is parallel to the given line here, vector R. Given line, it is parallel to the given line. Let me mark this is L1, L2. So given that the given line is parallel to the vector B, that is equal to vector I minus 2j plus k. So therefore a required line is also parallel to the same vector. So in that case, for getting the parametric form, let me take, so the required line is, the required line is passing through -1, 2, 1 and parallel to vector B is equal to same vector, I minus 2j plus k vector. So you have to find the parametric form. Parametric form is vector R is equal to, let me take the point as C plus T, same parallel vector. So vector R is equal to, C is here minus I plus 2j plus k plus T into vector B, I minus 2j plus k vector. So this is the parametric form of the equation. And see the next question, find the shortest distance between the parallel lines. Here, so the distance you have to find. So they passes through two different points but parallel to the same vector. So the formula given for you is distance is modulus C minus A cross vector B divided by modulus vector B. So what is C minus A? Vector C minus A. Vector C is a given point minus I plus 2j plus k vector minus A vector is a point for the given line. Given line is 2i plus 3j minus k. 2i plus 3j minus k. So you subtract this, you will get minus 3i minus j, then plus k, this is plus 2k. So let me find the cross product of, and also already I have written vector B. So vector B is equal to I minus 2j plus k. Find C minus A, vector C minus A cross vector B, that is I j k. C minus A, minus 3 minus 1 2, 1 minus 2 1. So you will get here I into minus 1 minus 2 plus 2, that is plus 4, minus of minus 4 plus 4 minus j into minus 3 minus 2 plus k into 6 minus 1, that is plus 1. 3i minus plus 5j plus 7k. You need to find modulus. So modulus of vector C minus vector A cross vector B. This is equal to square root of 3 square plus 5 square plus 7 square. 9 plus 25 plus 49. That is square root of, your answer is adding 83. Next you have to find the denominator term is modulus vector b. So modulus vector b is square root of, psi coefficient is 1 square minus 2 square plus 1 square. That is square root of 6. So what is distance? D is equal to, just one time we have written modulus vector c minus a cross b. That answer is square root of 83 divided by modulus vector b is square root of 6. You can mark this as 1. So from 1. This is the answer. Thank you.